Welcome to the Urbano Hydra webinar. My name is Mihael Vajic. I will be your host today. And today we will have the first presentation of Urbano 11. And we will start with Urbano Hydra, so with water distribution system design. So after this brief introduction, we will go to the live presentation, which will last about 1 hour. And then we will have questions and answers afterwards. So if you have a question, please write it into your questions panel. And we will try to reply to all the questions live, and if it's not possible, then we will do it after the event. If you have any kind of issue, you can also write in the questions panel, or you can write in the chat. Okay, so for those of you who are not familiar, Urbano software has celebrated more than 30 years of development some time ago. So Urbano software allows you to do a lot for pipe network systems design. So you can do design in plan and profile, also calculate and optimize pipe networks, analyze networks with thematic maps, with labels, tables, and even queries, and many other features. You can connect GIS systems, CAD, hydraulic modeling, and BIM all into one workflow without leaving your CAD software. And there are a lot of customization functions, so you can customize profiles and labels and data tables and data import and export and many other things, catalogs, the user interface, and so on. Okay, so let's now start with the live presentation. So Rino, please take over.
Thank you, Michael, for your introduction. Hi and hello to everyone. My name is Rino and welcome to another Studio Ars Urbano webinar. Today's topic will be Urbano Hydra, our software for water distribution network design, analysis and hydraulic calculation. And in the following 50 minutes of live presentation, I will show you full workflow from the creation of the network in plan and profiles to hydraulic calculation and exporting of 3D BIM model to IFC. During the presentation, I will also show you some very exciting new features of Urbano 11. So let's start with the live presentation. As you can see in this drawing, I basically have just empty drawing with just this raster image of the area. And every time you start a new project, basically you have to have some data, like surveying data to create DTM and some rasters. But in Urbano, even if you don't have any of that data, you can always download it directly from Google Maps. So if we go to import from Google Maps, you can download the terrain and maps using two different options. First way is by going directly to Google and searching for the area of interest. This is Novi Vinodolski in Croatia. So you can just select it, download it, and one map will be downloaded. But also in version 11, we added a new possibility that you can directly in CAD define a coordinate system, and then you can select a polyline, draw the area, or select the current view. Here, if I just switch the layer state, I have one polyline here already drawn. So I will select this polyline, and now I can define a zoom factor. The higher the zoom factor is, the more maps will be downloaded and the maps will be of higher quality. Also, we can create AutoCAD clipping boundary according to that selected polyline. We can download raster, points, or everything, but I already have real DTM for this area, so I'll be downloading just rasters. So when we click import, in a matter of seconds, everything will be imported. So these 9 maps, and now we can check it, and we can see that the downloaded maps fit perfectly to this existing raster that I had from before. Let's check this area here. So this is the way how you can draw the maps and also points with elevations directly from Google. I said that I already have DTM in this drawing, so I will just show it to you now. So these are the real surveying data that I have for this area. So 3D points and lines with elevations that I used to create this Civil 3D DTM surface. It is important to say that if you run Urbano on top of Civil 3D, you can use Civil 3D DTM surfaces directly, but also if you run Urbano on top of plain AutoCAD, you can use our own DTM modeler, which is called Terraform. And now if I apply this DTM surface, you can see that basically there is no difference. So it's up to you if you want to use Civil 3D DTM surface or Urbano Terraform DTM surfaces. Okay, let's again switch the layer state and let's now start designing our water distribution network. Here I have some helping polylines and also helping points that I will use to create this network. So here we will have a water tank. This will be a pipeline from the tank to the distribution network, and this part we will draw interactively. And here we have some existing AutoCAD polylines, 2D polylines, that we will convert to pipe network. Okay, so let's start drawing. First, I will open the function for interactively drawing in plan. And here you can see that you can set up many options. For example, we can automatically label the nodes and sections. We can automatically set elevations to be read from the selected DTM surface. We can automatically place pipe on a constant depth below terrain. And also we can select pipe group and pipe diameter from the pipe catalog. So now when we click draw, I will use the AutoCAD OSNAP just so I can snap to these helping circles. And you can see that I can draw freely without some predefined angles, or I can go to the dialog to angle configurations. And here you can select the default configuration, which is all angles, and basically all the combinations of these angles, or you can create your own custom configurations. For example, here I created one configuration without angles 30 and 60. And now if I select one of these configurations, for example, all angles, you can see that now I can draw only using these predefined angles here. Or if I switch to a different configuration, let's say without angles 30 and 60, you can see that now I have less available angles. So let's draw this part of the network using these options, using this compass like this. And at any point, if you would like to turn this option off, we can go back to dialog and just reset to none. Okay? And let's now just connect to this node. Now I would like to switch from drawing the line sections to drawing the arc sections. And again, you can see that I can draw the arcs freely, or I can define exact radius here in the dialog. You can type your own value, or you can select the radius from some predefined values from the list. Let's say 50 meters. And now you can see that I can draw radiuses just with that exact radius. So again, let's use these helping points. And notice that each new line section that I draw is immediately tangent to the previous arc element. And also each new arc element is automatically tangent to the previous line element. Okay, let's continue drawing. And notice that how I am picking the DTM elevations are automatically read, and also the pipes are being placed on a constant depth below terrain, 1.5 meters below the terrain. Okay, let's end it with one final line section, and we will snap to this circle here. So we defined first part of this network by drawing interactively, and now we will go to second option, conversion of CAD elements, where you can see that you can set up all the same options as in the dialog before, but also you can use this very nice function for layer filtering. So you can select some elements in plan, like this, some lines or polylines, and the software will recognize which layer this is, and now we can freely select the entire drawing, and the software will select only those elements on selected layer. Let's now click convert, and everything will be converted from plain AutoCAD polylines to intelligent Urbano topology consisting of nodes and sections. Okay, let's now turn off these helping layers so we can focus just on the Urbano network, and let's analyze it. And the best way to analyze Urbano network is by using Urbano data tables. And you can see here in Urbano workspace that for each function, for example, data tables, labels, profiles, theme maps, basically everything, you can have many different configurations. And these configurations are basically sets of some predefined data, settings, and options saved for each function. So let's open now these data tables, and you can see that you can switch between these configurations and check the data. Of course, you can create your own configurations or edit these ones. And here we see all the data for all the system, or you can use selection options to select just some of the elements. For example, let's select just few sections from plan, like these 3 sections, and now we can check just the data for those 3 sections. But in Urbano, we also have some more intelligent selection options, for example, selection of branches. And now let's see what is a branch in Urbano. A branch is everything in between 2 main nodes, so everything in between branching of the network. So if I select these 3 branches, we will get all the sections that belong to these branches, but also we can switch to a different data configuration, branch geometry, where we can see the total data for the entire branches. Also in Urbano we have something that we call arrays, and arrays are basically arbitrary topological elements that you can create by yourself, but by default you can see that one original CAD polyline that we converted became one Urbano array, and this part that we draw interactively is also one array. So now if I select these 2 arrays, I will get all the sections and all the branches in those arrays. And again, I can switch to array geometry and see the total data for the entire arrays. Like I said, we can edit these arrays by merging them together or breaking them. So here we see we have these 2 arrays, one that I draw interactively and one that I converted from CAD polyline. So let's now go to function for editing of the arrays, merge, and I will select these 2 arrays and let's merge them to array A1. Okay, and now we can see that this is now one array. Okay, let's select now the whole system and let's rename these arrays. You can rename all the elements directly through the data table by just picking inside of these white cells. But I would like to show you one new function in Urbano 11, which is function for renaming of the arrays according to rules. In this function, you can select one of 3 rules for renaming, and I will use this first rule according to arrays hierarchy. Basically, you just have to select the main array, arrays to be renamed. You can give the main array name and set some delimiter. And now when you click rename, all the arrays will automatically be renamed according to this rule, according to the hierarchy. So this is the main array, A1. Then we have arrays A11, 12, 13, and 14 that are directly connected to the main array. And then we have A111, 112, 131, and 132. Okay, let's now also rename the nodes. So let's switch to the node geometry data table where we can see all the data about the nodes, including the default names. And there are many different options for renaming everything, but for nodes, I like to use the option to rename the nodes so that the name of the array is a prefix of the node name. So let's select the entire system. For the prefix, I will put the array name like this, put some delimiter, and apply the changes for the entire system. And now you can see that we have the array name as prefix and we have the counter. So now everything is renamed and everything is rename basically how I wanted these elements to be, but like I said, there are many functions, interactive or automatic, how you can name your elements. Okay, so now that we know everything there is to know about Urbano topology and selection options, let's draw profiles. To draw profiles in Urbano, it's extremely easy. It's basically just select a profile configuration. And like I already said, everything is saved inside of those configurations, from scale to language to colors to data. So let's select entire network. We will draw the arrays according to these arrays, array topology, and we can define number of rows and number of columns. And now with just one click of a mouse, we can get all the profiles for the entire system. Another great option how you can draw your profiles is by using selection option from node to node, where you can basically go from any node to any node in any direction. I will go through this node all up to the last node of the system, and I will place this profile here. Let's now take a look at those profiles. And if you remember, we placed the pipe position to be on a constant depth below terrain, 1.5 meters. But in Urbano, we also have many different functions for precisely defining the pipe elevations directly in profiles. So let's now show this. But before I do that, I will draw some helping lines, some auxiliary lines, terrain parallels. I will do it for all the profiles, 1 meter and 3 meter below the terrain. Let's click draw. This is a very nice function because we can see if our pipes are on some places, let's say too shallow or too deep below the terrain. So for example, if this is an issue, we can resolve this very quickly by using one of these options for editing the pipe elevation in profiles. I will use this option where you can basically straighten the pipe by line or by slope. So just select the entire profile or some part of the profile from node to node like this. And now we can straighten it by line by defining starting or ending depth or elevation. Let's, for example, change the ending elevation to 2 meters like this. We can apply the changes, or we can straighten it by slope by defining again starting depth or elevation and slope. Let's round this slope, for example, to exactly 5 promiles, negative 5 promiles. And now when we click apply, you can see that in the profile table, the slope is exactly 5 promiles for this part of the profile. Of course, now we could continue editing pipe elevations in all profiles, but let's say that this is our final solution for the pipe elevations. So I will close this dialog, and also I will delete this helping terrain parallels. Okay, so the next step would be to assign air release and washout valves. To do that, I will go to Hydra panel and I will run function air release and washout valves. We can set these elements interactively by selecting some nodes in plan or in profile, or we can do it automatically by selecting the entire network and just clicking apply. So how this function works, it basically searches for the highest and the lowest inflection points where the slope is changing from negative to positive or from positive to negative, like this, and is placing this air release and washout valves. You can see that these custom blocks automatically appeared in profiles, and also if we zoom to those same elements in plan, you will see that the custom blocks appeared in the plan also. Okay, so now that we defined air release and washout valves, let's place them into some kind of manholes. So to set manholes in Urbano, we go to function for setting of the manholes. From the manhole catalog, you can select type of the manhole, manhole material, manhole size, basically many different types of manholes. I will use this rectangular manhole with rectangular opening. You can set up some parameters. And now I will select the entire drawing, but I will use node type filtering to select just air release valves. And I will click save. I will repeat the procedure, but just for washout valves now. And you can see in plan how the style, the 2D plan style is automatically updating. So when there is no manhole, we see a custom block, but when we apply a manhole or the pipe, we see the realistic 2D plan dimensions of the pipes and manholes, because this is the default style that is applied. Of course, you can see the blocks if you change how the elements are shown in plan view. Additionally, I would like to set a manhole everywhere where I have a branching in my network. So let's turn off the filtering, and I will select all the nodes where I have more than 2 pipes, because here we will have some fittings, some T-pieces, some valves, appurtenances, and so on. So just pick them like this, and I will click apply. So now we can see that we have also the manholes on these positions as well. Okay, so at this point, I would like to switch to another drawing, which is basically this same project, this same drawing, but I have some stuff predefined here so we can move a little bit faster through the presentation. So in this drawing, first of all, I'm going to set a water tank here in the first node of the system. To do that, let's go to Hydra panel, hydraulic node equipment function, and I will select this first node. It is important to say that Urbano Hydra works with EPANET calculation engine that is built inside of Urbano Hydra. So here you can see that we can set up all the EPANET available equipment, such as tanks, reservoirs, valves, pumps, and so on. So let's select a tank. We can also define all the available parameters, but I will leave everything as default. And let's click apply. You can see that the custom block automatically appeared in plan, and also it appeared in the profiles as well. The next step would be to define water demands. In Urbano Hydra, you can define water demands using many different methods, but I will show you 2 methods. First one is this, as we call it, percent calculation, where you can create any amount of the consumption categories. I created one that I called population, and here you can basically just select the area where you want to apply the water demands. You can use standard Urbano selection options or even CAD selection. So I will select this, what I said, that it will be a distribution network, this. We can define now water consumption per inhabitant in liters per day per 1 inhabitant. I will set it to 180, and you have to define number of people living on the selected area, let's say 5,000 people. Also, you can set up some coefficients like coefficient of variation per day and per hour. And when we click write, everything is calculated and water demands are set to each of these nodes in selection. Then also we have standard way of setting water demands, basically point demand, where you can just select some nodes in plan or in profile like this, and then you can set the same value to all the nodes in selection, or you can go through the data table and basically define different or same values for each nodes. Okay, let's reset this, because I would like to set just one point demand to this node here. Let's say this will be some kind of industry here that is spending 6 liters per second. And this will be our basic water demand to do hydraulic calculation for this system. But I will not go to plain hydraulic calculation to do hydraulic calculation according to the existing pipe diameters, because if you remember from the first drawing, I defined those pipe diameters quite randomly. We will go to function for pipe optimization, which is a great function that can optimize your pipe diameters and give you the best possible diameters for your network. Here you can divide the network in some kind of zones or groups to achieve as better as possible diameters. So I divided this network into 2 groups. First one is transport pipeline, and second one is distribution network. For each group, you can define target velocity as a single value or diameter dependent value. And also, for each group, you can select pipes from the pipe catalog that will be used in calculation for that group. When we click Start, you see that the pipe optimization process starts. by using genetic algorithms to give you the best possible diameters so that the real ending velocities are as close as possible to defined target velocities. Okay, now the calculation is done. We can save the results. And here you can check the ending diameters, flows, velocities. So these are the real velocities. These were the target velocities that we defined. And here we see the differences between the real and target velocities, and we can see that the results are quite good. Okay, let's close now this and let's check the results. We can see that the profiles automatically updated. So we have the piezometric lines showing now. And also if we go to plan, we can see that the plan styles and also labels in plan also automatically updated, showing us the new pipe diameters. We can also put the hydraulic calculation results data into the labels as well. So I will just switch the label configuration. I will apply the default labels. And now you can see that we have now pressures showing in the labels for the nodes and flows and velocities showing in the labels for the sections. Now that we added more data to our labels, we can see that some of the labels are overlapping, but you can solve this really easily by moving some of the labels interactively, or we can run automatic label reposition, define some parameters for label moving, and when we click apply, all the labels in the entire drawing will be automatically moved by those defined parameters so that there is no more overlapping of the labels in the entire drawing. Okay, let's now analyze the hydraulic calculation results using the data tables. Let's switch to section hydraulics and let's check the velocities in our network. We can see that the highest velocity is around 0.80, which is great for the selected diameters. And also let's now check the smallest velocities. And we see that the smallest velocities are in these ending parts of these branches, but this is something that we expected to happen because these are these basically dead ends. And let's say that the velocity results are pretty good, but let's check the pressures. So if I switch to node hydraulics results, we can again sort it by pressures. We can see that we have some very low pressures, but again they are happening here close to the water tank outside of the main distribution area, so that's not problematic also. But if I sort it by highest pressures, I can see that I have some very high pressures, higher than 70, happening in this lower part of the network. So another great way how you can analyze this hydraulic calculation results is by using thematic maps. So let's go to function for applying theme maps. I will select velocity for the sections, and also I will set pressures for the nodes. Additionally, I will apply the pressure contours using the same color coding as for the theme maps, like this. And now you can see in these legends and also in plan view all the different parts of the network, so we can see where we have some velocities that are too low, or let's say pressures that are too high. So the only logical solution would be to place one pressure reducing valve to this node here. So first of all, let's delete these theme maps. Let's also delete the pressure contours. Let's go to this node. Let's go to Hydra panel, hydraulic node equipment. I will select this node and I will set it up to be a pressure reducing valve with the reduced pressure setting of 35 meters. Let's click apply and notice that nothing will change automatically except for the block. We have to rerun hydraulic calculation to refresh the results. So just click calculate, save, and you can see that now everything is updated. We have this pressure drop happening in this node, and we can also go to profile and we can see this pressure drop happening because of the pressure reducing valve that we defined in this node. Okay, so now again, I would like to switch to a following drawing, which you can see is again the very same project with some stuff predefined. So let's show the differences, what is new in this drawing. So again, let's open the water demands dialog, and here you will see that I added another consumption category for this percent calculation, and I called it tourists, and I intentionally assigned very high amount of water and very high amount of people for this consumption category. So 250 liters per day per one tourist, and also 10,000 people. Additionally, I defined 4 firefighting demands of 10 liters per second to each of these last nodes of these branches. So you can see this firefighting demand, so 10 liters per second in each of these last nodes. So you can create any amount of these consumption categories, and then you can basically group them into scenarios. So scenarios are basically just groups of these previously defined consumption categories. So I created 4 scenarios. First one is just population with point demand. Second one is with tourists. The third one is just one firefighting demand happening without the tourists. And the fourth one is basically everything. So everything that I defined, all the consumption categories. Basically, you can create any amount of these scenarios, select whatever consumption categories that you would like, and then we can go to scenario preview, and here we can basically do parallel hydraulic calculations for each of these scenarios. So just clicking them, you see you can define the colors, and now we can check all the results for all the scenarios and basically compare hydraulic values for different scenarios, for different data in different colors. So we can see flows, velocities, hydraulic losses, all the data can be compared and analyzed for each scenario by checking data by data or by checking all results for one scenario with all results for another scenario. So let's now close this and let's go to hydraulic calculation, and I will run a hydraulic calculation according to one of these scenarios. So hydraulic calculation, and I will use as a demand scenario this fourth one where I have everything, so 4 simultaneous fires and very high amount of tourists. Let's click calculate and let's save the results. And now you can see that in the errors tab we have some errors or warnings in this case, and we see that the EPANET is warning us that we have a negative pressures happening on this area here, because logically I defined very high amounts of water demands. You can see that the piezometric lines are very steep, and in this profile we also have the negative pressures. So let's go back to preview and let's select this profile where we have these negative pressures happening. Okay, and let's check the results of pressures. So if I switch to a default preview for the nodes, I can see that from this point to the last node of this profile, we have negative pressures. And of course, in nature, this is not realistic. And that's why in EPANET 2.2, which is integrated into new Urbano Hydra 11, we have a new option, new calculation method. So under demand model, you can choose between demand-dependent analysis and pressure-dependent analysis. The default is the old way, so demand-dependent analysis, which means that whatever amount of demand is defined, everything will be delivered to customers in full. And of course, it may result with the negative pressures, which is not realistic in nature. But if we switch to pressure-dependent analysis, you can define what is the minimum pressure, let's say 1 meter, which means that if the pressure is below this value, no amount of water will be delivered to the customers. Required pressure, I will set it to 25, which means if the pressure value is between these two values, then the amount of water that is delivered will be calculated by a formula. And if the pressure is higher than 25, this means that the whole demand that is set, the full demand will be delivered to the customers. Let's click OK and let's rerun the calculation. Now you can compare these are the old values, and inside of the brackets you can see the new values. So here, where the pressure is higher than 25, nothing changed here for the water demands, but when the pressure is higher than lower than 25, you can see that the demands are not delivered in full anymore, they are calculated. So let's save the results and we can check this. So these are now the new results. When the pressure is smaller than 25, we see that we have smaller values of demands, but there is no more negative pressures happening anymore. So this is one very nice new feature of EPANET 2.2 and also Urbano Hydra 11. Okay, so again, let's switch to a following drawing where I would like to show you time simulation in Urbano Hydra. So as you can see, I added additional part of the network by using the same options that I showed you in the first example. This is where I assigned one reservoir. Here we have a pump with a pump curve. And if I again open the dialog for water demands, you will see that for each consumption category, I also defined a time pattern. So for the population, for tourists, and also for firefighting demand. Additionally, if we go to controls and rules, you will see that I defined two rules to control my work of the pump. So when the pump will be shutting off or turning on in relation to water level in the water tank. Okay, so now that we have all this defined, we can go back to our hydraulic calculation dialog, and I will do a basically time simulation using this demand scenario, this just one firefighting demand in this last node of the last branch without the tourist, because I would like to have the normal amounts of water again. And before we click calculate, let's go to options to check that we can define time options. And for total duration, I set the time to 24. So we will do 1 day time simulation. And let's click calculate and let's save the results. You can notice that each time you click calculate in Urbano, this EPANET EMP file is created. So if you need it, you can open it directly from the software in EPANET. We don't need it basically, so I will close this. Let's go back to Urbano. And now you can see that we don't have just one set of results anymore. We have now 28 sets of results. So one for each of the 24 hours of the day. Plus we have some values when something is happening with the pump, when the pump is shutting off or turning back on. Okay, you can analyze all the results for all the system elements and then move through time like this. Or you can switch to time preview and then select just some element from the drawing. For example, I will select this last section where we have this firefighting demand. And now we can see for that one element, all the results for all the values through all the time periods. So again, you can go through time and check the values, or you can go through the drop-down list and let's select, for example, 4 o'clock p.m., where we can see that we have our peak flow because of the 2-hour time pattern here for the firefighting demand. And of course, if you want to apply some time period, let's say this peak flow, we can apply the time and notice how the profiles, these piezometric lines automatically updated, the labels automatically updated, everything. But the best way how to analyze these time simulation results is always by drawing some graphs. So let's go to time series graphs. And for data 1, I would like to see the pressures in the water tank, meaning the water levels in the tank. So let's select this tank. And for data 2, I would like to select velocity and check this section right after the pump. And now you can see two different values in the same graph. So we can check how the water level in the tank is rising until it reaches maximum value. Then that rule kicks in, the pump is closed. And again, when the water level in the tank drops to 1, the pump is back on. Okay, so that's pretty much it that I wanted to show you regarding the hydraulic calculations. And let's now switch to a different topic, and we will talk about trenches and excavation calculation. So I will turn off these helping layers and let's check our profiles. You will see that in profile we have the trench now defined. I defined a single 90 degrees trench with sand bedding, and you can see that I also defined two types of the top layer. So up to this point here, I defined two layers of some kind of earth material, and from this point on, I defined two layers of asphalt where our pipeline is going under the road. We could check this much better if we draw cross sections. And again, to draw cross sections in Urbano is very, very easy, just like drawing the profiles. You just have to select the cross-section configuration and all the settings are set inside. Let's draw cross-sections along these two arrays. For example, every 25 meters along these two arrays. Let's click draw and let's place these cross-sections here. So with just one click of a mouse, 55 cross-sections are drawn and we can check them. And you can see the type of the trench that I defined. So like I said, classic 90 degrees trench with formwork and with sand bedding. And you can see everywhere, everything that I said. So all these hatches, colors, data, dimensions, everything is set into these configurations. And also you can see these two different types of top layer, and you can see all these cross-sectional areas for each of the layer of the trench. So now that everything is defined, let's also create excavation calculation report to Excel. I will run this report, select the entire drawing, group it by arrays, and let's click Save. Again, in a matter of seconds, this report will be created, and we can open it directly from Urbano in Excel. And now you can see that for each section, we have starting and ending station, total excavation volume for the entire section, excavation volumes according to depth excavation zones, which can be set up by the users. We see the volumes of the upper layers, and then also volumes of sand bedding, pipe volume, sand bedding, sand backfill, ground backfill, formwork area, surface area, everything is here. You can see that the report is grouped by arrays because that's how we defined in Urbano. And if you scroll to the bottom of it, you will see what is most important, and that is sum of data for the whole network. Okay, let's now go back to Urbano and let's plot these cross sections. In Urbano 11, we have a new function for plotting these kinds of drawings like manhole schemes, node schemes, trenches, and so on. So let's go to Tools, Plot Schemes, and Cross Sections. We will plot cross sections. I will select all of them, and you can now define the paper format, some standard paper options. You can select a title block or just leave the empty space for the title block so you can later insert it manually in the layout. We will draw maximum number of these drawings per paper. You have to select, or you can select the layout template, AutoCAD layout template that I prepared. And also we will draw folding marks so we can easily fold this A2 paper to standard A4 format. So let's click plot, and in a matter of seconds, these 55 cross sections will be drawn to two A2 papers. And now we can check it. So this is the result. You can see all these cross sections. You can see these folding marks. So you can easily fold the paper to A4 format when you plot it. And here we see the empty space that I intentionally left blank so I can insert my standard title block. And this is the second paper as well. Let's go back to model view. And now I would like to show you what's new for the profiles in Urbano 11. Let's open the function for editing profile configuration like this. And first big news is in relation to these piezometric lines. So let's select the piezometric lines. And now you can see that you can turn the option to draw values. This is very useful. So let's click apply and let's check it. Now you can check the piezometric line values here directly in the profile above the piezometric line itself. Okay, the second new feature is also in relation to piezometric lines. You can trim them. So just turn it on, you can apply some settings, and when you click apply, where it is possible, the software will trim these piezometric lines and make your profiles shorter, which can be very useful if you plan to plot these piezometric lines. But of course, this is possible only where the terrain is flat, so the trimming is possible. Of course, here, where the terrain is very steep, there is no possibility to trim the piezometric lines anywhere. Another great option is the new possibility that you can now draw the grid. So just turn it on. You can define, of course, horizontal and vertical distances. And when you click apply, the grid will appear, of course, in all the profiles, because this is now part of the profile configuration. And the last news is actually really small detail, but a lot of our existing users asked us to do this, so we did it. So it's in relation to these vertical texts. Now you can draw them on a vertical line with some kind of a horizontal offset. So now if we apply this, you will see that this vertical text will appear on a vertical line with a horizontal offset. Okay, I mentioned this multiple times, but it's really good, so I will repeat it one more time. So everything in Urbano is structured with this type of configuration. So at any point, if you want to change your profile configuration, for example, you can easily do it. For example, you can have your design configurations, and when you want to plot the profiles, you can just easily open the profile manager, select all the profiles, and just easily switch it to another configuration. For example, with different language, different scale, different data, or whatever. So now we did this, and now if we check our profiles, it looks completely different. We have some different colors, different data, and in general, basically just different visual appearance of these profiles. Let's now plot the profiles to layouts. So in Urbano 11, again, we have a new function for plotting, which is really easy to use. So basically, again, just select the profiles. I will select all of them. You can select a paper format. I will use this paper roll with these dimensions. Some standard paper format parameters. You can again select a title block or just leave the empty space. And first of all, we have to draw a helping frames. So let's draw the frames. Sorry, I clicked delete. So draw the frames. You see that all the frames are now drawn. And now we can plot these frames to layout. We can plot for all the profiles, but I will select just some of them so we can plot it a little bit faster. For example, just these. And again, you can set up some parameters. We can select the layout template. Again, I would like to draw the folding marks to A4 paper. And when we click plot, everything will be plotted to layout in a matter of seconds. So A1 profile is quite long. So it's splitted on 3 layouts like this. And then we have A11, A12, A13, and A14. And again, you see that we have these folding marks here and also the empty space that is left for the title block. Let's go back to model. And now I will switch to a final drawing today, final example, where I will show you Urbano intersections, meaning clashes and crossings with other infrastructures. So here, as you can see, we have additional network in red, which is a newly designed sewage system that I imported from another Urbano drawing. But what I would like to say that whenever you draw something new, or in this case, import it from some external file source, which can also be Urbano, all the crossings and all the clashes will automatically be calculated and shown in all the profiles. So all the crossings, all the clashes are completely dynamic and completely automatic. If you want to see these some information about the crossings in plan as well, some kind of labels, you can do this as well by going to intersection panel, intersection settings. You can turn on automatic labeling and select one of these predefined label configuration, or you can create your own with some specific data. Let's click OK, and now you can see that the block appeared and some data. We see the distances, terrain heights, and also depths of both intersected pipes. If you have multiple clashes or crossings on a same area, very small area, you can of course remove or move these intersection labels like this very easily. If you need to have more data about these crossings and clashes, you can always go to intersection preview data table, where you can go through the table and check all the crossings and their data in plan or in profile. And here in the data table, you can see which systems these are, which pipes these are, which nominal diameters these are, and also we can see what is the relative position of these pipes. Is it a clash or collision, or some pipes are above or below selected pipes? Also, we can sort this data table so by distances, so we can see where we have the actual clashes, where the distance is 0, or where we have just crossings of the elements in plan. And here you can see that we have this for pipes with pipes, but also pipes with manholes and manholes with manholes. Also, we can filter the data table by clicking here, show only collisions, and now you can see clashes, pipes with pipes, pipes with manholes, like this, and fortunately here we don't have any clashes, manholes with manholes. So let's now start resolving these problems. So I will just use the move node function to move this water manhole, and basically you will see that by moving this one node, I will resolve 3 clashes here. You can see that now we have only one clash left in the data table, which is this one here, and again this is basically 3 clashes. So let's again use the function for moving of the node, and I will place this node here. And now you can see everything is completely automatic, completely dynamic. There is no more clashes in the data table. Let's go to pipe with pipe, and also you see that we have no more clashes. But let's increase the collision tolerance now to, let's say, 10 centimeters, because I would like to see the pipes that are very close one to another. And we see that we have one issue here, and these 2 pipes are very close, just 3 centimeters vertically one from another. And if I check this relative position, I can see that my water pipe is below the sewage pipe. This is something that I don't want to have. So let's zoom to the profile, but I will zoom to the sewage profile here, where you can see this water pipe. And now I will edit the sewage profile. So let's switch to the sewage system. And what is great in Urbano, that basically whether you are drawing and designing water network or sewage network or any other type of the networks, all the functionalities are basically the same. So I will start the same function for editing pipe elevations in the profile. For the pipe reference point, I will select top outer. We will be straightening by line, and I will select from this node to this node like this, and I would like just to insert a drop manhole here. So I will increase the starting depth to, let's say, 2.5 meters. Like this, we see this temporary graphic, how the ending solution will look like, and let's just click apply. So now you can see that the data table automatically refreshed. We have no more clashes. Let's turn off now these filters. And if we sort it by distances, now we can see that the shortest distance in 3D between any 2 elements is 33 centimeters. And everywhere our water pipe is above the sewage pipe. Okay, for the last part of this presentation, now that we have this clash-free model, let's also create 3D BIM model. To do this in Urbano, I will go to function for multi-system input, and I will apply a 3D style for both of these systems. So just click apply. So in Urbano, it's up to you if you want to work in 2D, showing your elements with standard AutoCAD lines and blocks, or you want to check your network in 3D using 3D solid elements. Let's switch to 3D view. And let's turn off these layers that we don't want to have in 3D. Let's now check these pipes and manholes. So like I said, these are the 3D solid elements, CAD 3D solid elements, but it is important to say that this is still live model. So if I change anything, like increase the pipe diameter or move something, everything will automatically update in 3D view as well. Let's now export this to IFC. I will go to BIM panel, where we have our data configurations, because when we talk about BIM, it's not just about 3D, we have to have some data as well. So you can create groups of data that you will export with your network. So geometry data I created, for example, excavation data, sewage and water hydraulic data. Okay, and now when we go to IFC export, but it's completely the same for Navisworks NWC export as well, you can select which pipe networks you would like to export and also which DTM surfaces. And for each system, you can define which of these previously defined data groups you would like to export for each system. And now when we click export, in a matter of seconds, this will be exported to IFC. And now you can open this IFC, for example, with Navisworks that I will use, but also with any other BIM viewer that you like to use. So this is our final BIM model. You can see this Civil 3D DTM surface that I will hide because I would like to focus on just on Urbano pipes and manholes. So let's zoom, for example, here. And now if I select, for example, this water pipe, we can see all these data groups, these tabs of data that we exported from Urbano. So geometry data group, excavation data group, water hydraulic data group. So even in this BIM software, we can see all this hydraulic calculation data, hydraulic modeling data that we calculated with Urbano Hydra. Okay, so with this, we conclude this today's presentation. I hope you liked it. I hope you would like to test it and try it on your own projects. And now, before we go to Q&A, I will give a final word back to Michael. Thank you all.